Hello, everyone. Happy to be here, Dr. Sharkey. I have had a career in quantum technologies for the last 20 years. I started my business in 2018, and I can say that it has been a very cross-interdisciplinary endeavor for me, such that I have been awarded most influential figures in quantum technologies by Alpha Events, the Hot 10 2025. And I've also been awarded 40 under 40 for cybersecurity. But traditionally, I'm a chemist. I am a quantum chemist, and I understand quantum mechanics from a very fundamental level. I went through the National Science Foundation Innovation Corps program where I interviewed many different archetypes and different industry verticals to understand the pain points that the industry is facing. To continue on about what it is that I'm actually developing, let's see, slides. Um, Quantum computing hardware manufacturers do face some issues with moving past noisy scale intermediate devices. And there are bulk material noises depending on the kind of platform or modality that a quantum computer is built off of. But then there's also small sources of noises that, for instance, ion traps are going to have electric field heat noises. And what we need to be able to do is understand from a very fundamental quantum mechanics ideas where the noise is actually coming from. So how can we better understand purchasing the lasers, how to tune these lasers, and so on and so forth. So that's kind of been the effort that I have put together for my particular value proposition. I want to solve energy problems, and especially specifically around chemistry. So how can we be using quantum qubits, right, to describe chemical states of matter with a higher level of accuracy and precision, right? So this has been a long time for me to understand these kinds of things. And what's really interesting about the technology that I'm developing is that I create very accurate wave functions. So if a quantum computer technically is a camera taking a picture or a measurement of a physical system, I am creating a sort of compass to help the quantum computing manufacturer hone in on the actual wave functions that the qubit states are in. Okay, so I call this quantum virtualization as a service. The technology is called CLEAN, for quantum logical electrons and nuclei. It moves past the standard approximations that were invented in the 1920s by the founding fathers of quantum computing or quantum mechanics. And it's a really fun to be able to kind of look at these pictures where qubits actually have the vibration from the heat noise. So business model for my company is to contract with hardware solutions and be able to understand their problems from a more engineering perspective, and then create algorithms to help them create new solutions. Those algorithms can then be licensed into current software package providers, which they have a complete distribution channel. And of course, I can use Amazon platform for hybrid computing. So that's really interesting there. But all in all, my team has over 120 years of quantum experience, and so what we do is we come in and we do coaching. I have gone from the Department of Air Force information technology conferences all the way to banking conferences to do trainings. I've also gone into academia with universities and coached quantum adjacent professors in quantum technologies to enhance their teaching platforms. Further, I have also written a book, Quantum Chemistry and Computing for the Curious, that was recently named one of the top 10 chemistry books of all time. So that's been really exciting. And so I like to focus on corporate training and coaching. That's my primary focus right now, is to get that workforce development enhanced so that we can increase the adoption of quantum technologies, as well as moving past noisy scale intermediate devices. As a co-founding member of the Quantum Economic Development Consortium, I am leading a workshop next week at the plenary meeting on quantum chemistry. I'm very excited about that. And another group I work with is called the InfraGuard, which is a public-private partnership with the FBI. And I run a program there called Quantum Technologies and Cybersecurity. And I work with the 16 critical infrastructure sector stakeholders to help them understand better what quantum technologies can be doing specifically around cybersecurity and other aspects with quantum computing. And with that, I will go ahead and stop sharing. Thank you.